So, good morning. So, we were talking about electrochemistry revision, right? So, that's what we were discussing. 1 minute. Okay. So, with respect to last class, so we have discussed about anyone? We have discussed about only 2-3 members are there. Okay, fine. So, what we were discussing in the last class? We were talking about galvanic cell, right? Then we were talking about reduction potential or reducing potential, whatever it is. So that's where we have the concept which we have discussed in the last class. Okay. Now, based on that reduction potential, we have assumed or we came to know that zinc is going to donate the electron to the copper, but copper cannot donate the electrons to zinc. So what I mean to tell here is, when it comes to the zinc, it can donate 2 electrons to cupric ion, and due to that cupric ion can become copper. But this cannot be happen in a reverse direction. This cannot happen in a reverse direction where copper is going to donate the electron. So what I mean to tell you is, copper is going to donate the electron to zinc plus 2, and which will become zinc. So this cannot happen. Okay. So that's where electrochemical series talks about. Now we have a condition. When I am talking about Daniell cell, what do you mean by Daniell cell? So Daniell cells are those where anode will be of zinc plus 2 and zinc, and cathode will be of cupric ion and copper. So when I am talking about Daniell cell, it's going to produce the net voltage of 1.1 volt. It's going to have 1.1 voltage. Okay. Now, under equilibrium condition, or if I maintain 1.1 voltage, then there will be no flow of electrons will take place. So what I will do is, I will supply the external voltage of 1.1 voltage, then there is no question of any flow of electrons. So why it is happening? Because we are from externally we are supplying 1.1 voltage. So 1 minute. So what I mean to tell you is, when I am talking about this particular electrochemical cell, that is Daniell cell, which is an example for voltaic cell, where anode will be of zinc plus 2 and zinc as a redox couple, and cathode will be of cupric and copper as its redox couple. Now, as they are connected, the reaction will happen and it's going to produce 1.1 voltage. Now, under second condition, what I will do is, I will supply from externally 1.1 voltage. Okay, I will connect all these electrodes and I will start supplying 1.1 voltage to that particular battery from outside. Now what will happen? There is no question of any reactions. There is no question of flow of electrons. So what I mean to tell here is, concentration of zinc and copper, zinc ion and copper, in their solution it will remain same. Okay. Now this process where copper is going to donate the electron to zinc plus 2 will happen when I will supply the voltage which will be greater than 1.1 voltage, which will be greater than 1.1 voltage. Externally, I will supply the voltage which will be greater than 1.1 voltage. So during that time, yes, this reaction can happen. So during that time, this reaction can happen, where copper will start donating its electron to zinc ion. There will be reverse flow of electrons will start. So that's what you should remember. Otherwise, under normal scenario, zinc is the one which is going to donate the electron to the cupric ion, but copper will not going to donate the electron to zinc ion. Now, copper can donate the electron to zinc ion when you provide the condition. So what is that condition? That condition is when you supply from externally. When you supply from externally a voltage which will be greater than 1.1 voltage, then yes, then there will be flow of electron from copper side to zinc ion will takes place. Fine? All of you have understood? So that's what we have discussed with regard to some of the questions. Now we will come to next part. Next part is related to one of the important concept that is called as Nernst equation. That is called as Nernst equation. Okay. Now, what do you mean by Nernst equation? What it talks about? It talks about the relation between cell potential, then it talks about standard cell potential and the concentration of the ions, metal ions involved in the process. So what is that Nernst equation talks about? Nernst equation talks about cell potential and its relation with respect to standard cell potential and the concentration of ions present or utilized in that particular condition. So that's where we have the Nernst equation. Hagadre, when I am talking about this particular equation, what is that? If I take Daniell cell as the example, if I want to write Nernst equation for that, then I can tell that cell potential is equal to standard cell potential is equal to standard cell potential minus ln RT divided by NF. Sorry, RT divided by NF, right? Log of or ln. Now numerator always it should be whether anion concentration means anode ion concentration or cathode ion concentration. That's where students will get confused. So I am talking about Daniell cell. And where I want to write the Nernst equation for the Daniell cell. So what is that Nernst equation? That is cell potential is equal to standard cell potential minus RT divided by NF, where R is the gas constant, T is the temperature, N is the number of electrons involved in the reaction, and F is the Faraday's constant. So all those values they will give, N value you should know. Okay. Now ln. Now the question here is which metal ion should come to the numerator and which metal ion should come to the denominator? That is the question. Anyone? Now please remember that on the numerator it will be zinc ion, which is the ion present at the anode side. Okay, there will be zinc ion which will be present at the numerator. All of you have understood? So that's what you should be knowing. Zinc ion in the numerator and copper ion in the denominator. Since we are dealing with the Daniell cell or any other cell, if I am talking about, you can apply the Nernst equation But only thing here is in the numerator, you should write those ions which will be present in the anode half cell. And denominator those ions which will be present in cathode half cell. Okay? So that's why we have the Nernst equation. Now, same way we can write this one in the terms of logarithm. Better one is with respect to the logarithm. 2.303 RT divided by NF log of zinc ion and copper ion. Zinc ion and copper ion. Okay? By multiplying 2.303, now I can apply logarithmic value scale. Okay? So that's why I have the Nernst equation. Fine? Now I can once again rewrite by calculating the value of RT and F. Now I can rewrite this one as E cell is equal to E naught cell minus 0.0591 divided by N log of zinc ion divided by copper ion concentration. All of you got the point? That's where we have the Nernst equation. So we can use this particular equation to solve the problems related to Nernst equation. To solve the problems related to Nernst equation. All of you have understood? So that's where we have the Daniell cell I have represented with respect to Nernst equation. What I mean to tell here is I have applied the Nernst equation to a given Daniell cell. So what you have to remember is when you are writing the concentration of ions, which one should be in the numerator and which one should be in the denominator, that one you should know. Okay? So that's where we have the Nernst equation. Fine? Now, if I go with this Nernst equation, if I want to apply the equilibrium condition, now at equilibrium, there is no generation of any voltage. There is no cell potential. It will become zero, right? So at equilibrium, E cell will be equal to 0. Right? So therefore, same equation, I will go with this one. Same equation, I can write it as 0 is equal to E naught cell minus 0.0591 divided by N log of zinc plus 2 ion concentration and copper ion concentration. That's where we have the condition at equilibrium, where cell potential will be equal to 0. Okay? Now, if I want to rewrite this one, I will write it as standard cell potential is equal to 0.0591 divided by N log of Kc. That is because there also I can write it as Kc, because the concentration at equilibrium. Therefore, I am mentioning it as Kc. So this is the relation between standard cell potential and equilibrium constant. This is the relation between standard cell potential and equilibrium constant. That's where we have the relation. Fine. Now, same way, this will be the Nernst equation. All of you have understood? Fine. Now, already we have discussed the relation between Gibbs free energy and redox potential. Already we have discussed. What is that relation? That is delta G naught is equal to minus NF delta E naught. This is the another equation which makes the relation between Gibbs free energy and redox potential. That's where we have three important equations. And yesterday also we have discussed another equation, that is cell potential is equal to redox potential of cathode and potential of the anode. This is another important equation. This is another important equation. Now, under which condition these four equations we should apply? To which type of problem we should apply these equations? That will be the question now. The answer is very simple. In your question, in your problem, if they have given the value of standard cell potential and if they have given the value of the ion, concentration of the ions, then no need to go for second thought. Straight away you can apply the Nernst equation to calculate the cell potential. All of you have understood? So now, for example, in which type of problem I have to apply the Nernst equation? That will be the question, right? For board exam they will ask. Now the answer for that one will be, if the given data includes concentration of the ions, and if the data includes standard cell potential, then straight away you can go for Nernst equation. You can apply the Nernst equation and you can solve it off. Now, but please remember, to solve the problem related to Nernst equation, you should know logarithmic values. You should know how to use the log. Fine? So that's why we have the application of the Nernst equation with related to your exam point of view. Now, when it comes to question where they have given equilibrium constant value, then they are asking to find out the cell potential, standard cell potential. Naturally, this will be the question. Okay? Now, normally, anti-log they will not ask. Because if I want to use the anti-log, the question will be in such a way that they will be giving this value, but you have to find out the value of the equilibrium constant. They will give standard redox cell potential value. Now we have to find out the equilibrium constant. Now we have to use the anti-log. Normally they will not ask, don't worry. So therefore, this equation can be used when they have given the Kc value, that is equilibrium constant value. But you should know every time, what is n. They will not provide that one. You should find out what is that number of electrons involved in the process. That one you should know. Then only answer for that. Finally, we have got another equation which is called as delta G naught is equal to minus NF delta E naught. Now this equation it can be applied. When they have given standard redox potential and when they have given n value you have to find it. They have given standard redox potential value and they have asked to calculate the Gibbs free energy. Then this equation you can apply. So depending on the situation, you should apply the equations. So what about first one? So this first equation can be applied when they have given half cell potential of cathode and half cell potential with respect to anode. Then you can calculate the cell potential. So what I mean to tell you is, to calculate the cell potential we have majorly two equations. Nernst equation and this is another one. Now Nernst equation can be applied when the given data includes these many things. Cell potential by this equation can be applied when you know the half cell potential with respect to cathode and anode. Fine? So that's where you should apply these equations based on the requirement. Otherwise your answer will be wrong. You are not going to get any marks even for your steps also. If you have applied the proper equation, but final answer somewhere there is a mistake with respect to calculation, then also you are going to get the marks. It will not be 0. You will get some marks because you have applied proper equation. Okay? So try to practice which type of problem we should use which equations. Fine? All of you have understood? Okay. So in that case, we will move to next one. What I mean to tell you is, we will solve some of the problems. Now, this is related to your board questions only. This is related to your board questions only. Okay. Now the question here is standard electrode potential. Standard electrode potential. Standard electrode potential for Daniell cell. For Daniell cell is 1.1 volt. Is 1.1 volt. Calculate the standard Gibbs free energy. Standard Gibbs free energy or Gibbs energy, anything is fine. Gibbs free energy for the cell reaction. For the cell reaction. Now they have given the one information of, that is Faraday's constant. 96,500 coulomb per mole. Okay, so this is the information they have given. Coulomb per mole. This is not the bracket, this is coulomb. Now, how to solve this one? Which equation we have to apply? Because we have many equations, right? First thing, what is this they are talking about? Daniell cell. They are dealing with the Daniell cell, right? Now if I want to apply the Nernst equation for the Daniell cell, that we know that it is E cell is equal to E cell naught, that is standard potential, minus RT divided by NF ln zinc plus 2 divided by copper plus 2. So this is one equation. Then we have another equation as delta G naught is equal to minus NF delta E naught. This is another equation. Then we have E naught cell is equal to, okay, so it will be 0.059 divided by N log of Kc. Log of Kc. So that is another equation. And finally we have E cell is equal to E cathode minus E anode. Okay, so I will keep this one here only. Okay, these are the four equations. Now this is the problem. Now all of us we know that among those four equations, Gibbs free energy is present here. No other equations they are having Gibbs free energy. So here they are talking about to calculate the standard Gibbs free energy. So naturally I can apply the second one. I can apply the second equation. So therefore, first thing I will write it as given data. So what is that given data? They have given about Faraday's value, 96,500 coulombs per mole. Right? So that's what one data I have. So coulombs per mole, that is one data, given data, what they have given. So what else they have given? Any other idea? Any other data they have given? Yes, they have given the another data by mentioning the Daniell cell. By mentioning the Daniell cell, they have given another data. So what is that another data? Since it is a Daniell cell, since it is a Daniell cell, so that means what will be the reaction? The reaction will be zinc plus cupric ion, which will become zinc plus 2 and copper. That means they have given the N value. So therefore N is equal to 2. Therefore N is equal to 2. That is the another information they have mentioned. May not be directly, but they have given a hint by telling that it is a Daniell cell. So N value they have given. So what else? They have given the standard electrode potential as 1.1 volt, and that means they have given the E0 value as 1.1 volt. E0 value as 1.1 volt. Now you have to just substitute these values into that equation. So therefore, this equation you have to mention minus NF delta E0. So now delta G0 is equal to minus 2 into F is 96,500 coulomb per mole. Write the units there only, so that final unit will get proper one. Then what else they have given? E0 value. So that means 1.1 volt. That means 1.1 volt. Fine. So if you solve it further, you are going to get the answer. If you solve it further, you are going to get the answer as E0 value is plus 1.1. So naturally, it should be minus 212, 300. Okay? So that is coulomb volt per mole. Coulomb volt per mole. Because these units we have to mention, right? So without unit, you are going to lose the marks. You have to apply the proper unit. So coulomb volt per mole. Now all of us we know that coulomb volt can be written as joule. Coulomb volt can be written as joule. So therefore joules per mole. Since it is an energy, gives free energy. So therefore we can mention it in terms of joule, which is the unit for the energy. So that's where we have got the final answer with proper unit. Final answer with proper unit. All of you have understood? So among these four equations, which one we have applied? Second one. Why second one we have applied? Because they have given the cell potential as 1.1 volt. That means E0 value they have given. Then they have mentioned about Daniell cell. That means N value they have given. Then they have given Faraday's constant value. So naturally, since they are talking about gift free energy, I can apply the second equation straight away. I can apply the second equation. All of you have understood? So this is how we can solve it. Now why CV became joule here? Because it's understood that volt is equal to anyone. We know that there is a relation between joule, volt and coulomb. There is a relation between volt, coulomb, joule and coulomb. So that's why by using that one, that relation, we have solved it further. Okay? Because volt is equal to joule by coulomb. So therefore, we can mention CV as joule straight away. Why we are writing like this? Because volt is equal to J by C. Joule by coulomb. So therefore, CV is equal to joule. Okay? So by using that one, I have written it as joule. Better to mention in terms of joule only, because we are dealing with the energy, Gibbs free energy. So this can be a type of problem which will be asked for you, and it will be for 2 marks. It can be for 2 to 3 marks. I think 2 marks. So 1 mark for the equation, which equation you have applied, and another 1 mark for the proper answer. Okay. So if answer is there, no unit, 1 mark is gone. Okay. Although answer is correct, but there is no unit. We have not mentioned the proper unit. Then 1 mark is gone. There is no half mark concept. Oh, I should have not unit. Okay, half mark concept is not there. So E cell is equal to delta G naught is equal to, okay. Now, based on these 4 equations only, one particular thing we solved. Now the question can be another one. For the following reaction, for the following reaction, 2 chromium solid, 2 chromium solid plus 3 cadmium ion aqueous getting converted into 2 chromium ion plus 3 aqueous plus 3 cadmium salt. Okay, this is the equation. For the following reaction, they have given Cr plus 3 divided by chromium, they have given the value, redox couple value, minus 0.74 volt. Then they have mentioned another redox couple also, minus 0.40 volt. Okay. Now you have to find out, or we have to represent the galvanic cell. Represent the galvanic cell for the above reaction and calculate the Gibbs free energy. Calculate the Gibbs free energy. Calculate the Gibbs free energy. Okay. So this is the question. All of you have understood? Question here is, for the following reaction, chromium with cadmium ion, but in the product it is becoming chromium ion and cadmium metal. Okay. Now they have given the redox potential, half cell potential for the chromium ion and chromium and cadmium ion and cadmium. Now they are asking to represent the galvanic cell for the above reaction and calculate the Gibbs free energy. Fine? All of you have understood? We have to calculate the Gibbs free energy. Now, naturally, before applying the equation, if you are solving, you can start solving this one. Okay. Now that's why this is the given problem. Now if I want to represent the galvanic cell, no need to write the picture. Representation. This one they will ask for 1 mark and all. Representation of galvanic cell. It's not a Daniell cell. Galvanic cell for this particular condition. First thing, you should find out which will be the anode and which will be the cathode. First you should find out which will be the anode and which will be the cathode. Because when it comes to the galvanic cell, anode on the left hand side and cathode on the right hand side. And similar pattern we have to represent the galvanic cell. First anode should come, then comes the cathode. So therefore, first we should find out which is the anode. So how to find out which is the anode? Just see that which is that one which is donating the electron. Now we can see that chromium is the one which is donating the electron, because from 0 it is becoming plus 3. That means each chromium is donating 3 electrons. So that means anode part, it should be this one. This should be the redox couple at the anode. Fine. So therefore, anode redox couple will be, redox couple is chromium plus 3 and chromium. Naturally, another one should be cathode. Another one should be cathode. Or half cell also you can write. Couple is cadmium plus 2 cadmium. Now we can easily represent the galvanic cell. That means chromium, which is solid, okay, so which is in connection with the electrolyte where chromium ion is present, okay, that is Cr plus 3 aqueous, okay, so where chromium ion will be there. Now they will be connected with a salt bridge. They will be connected with a salt bridge to another half cell, that is cathode half cell, where cadmium plus 2 is the electrolyte which is present in the electrolyte, which is in connected with the cadmium, which is in connection with the cadmium. So that's where we have the representation of the galvanic cell. This is where we are representing the galvanic cell. Okay? Since they have asked Gibbs free energy and the representation, naturally it should be for 3 marks. And 1 mark will be given here. Okay? For representing the galvanic cell, you are going to get the 1 mark. So this type of question for 1 mark you can expect. So what is that next? This is not the final answer. I will remove this one. But this is not the final answer. Halfway we are done. We have represented the galvanic cell for a given question. Now what is that next one? Next one is we have to calculate the Gibbs free energy. We have to calculate the Gibbs free energy. Right? That's what they have given, right? We have to calculate the Gibbs free energy. Now there is a problem. How to find out Gibbs free energy? How to find out? Observe it carefully. How to find out Gibbs free energy? Because they have given 2 values. Whether we have to apply both the twice we have to calculate delta G naught? No, that cannot be possible. So therefore, before going for application of delta G naught, first we have to calculate cell potential. So can anyone, which equation we have to apply first then? So we have to apply this equation. First we have to calculate the cell potential. So based on E cell is equal to E cathode, if you are doing under standard condition, minus E anode. Okay? Now, just now, before itself, we have found which will be the anode and which will be the cathode. So, which will be the anode? Chromium ion, and chromium will be the anode. And cadmium ion will be cathode. That's what we have calculated by doing the cell representation, galvanic cell representation. So therefore, since E anode is chromium plus 3 chromium, the value here is minus 0.74 volt. And with respect to cathode, it is cadmium plus 2 and cadmium. So for that the value is 0.40 volt. Now just substitute this value. I forgot this equation. So it will be for 4 marks then, not for 3. So therefore E cell is equal to, what is that cathode value? Minus 0.4. Okay, then what is that anode value minus 0.74 volt, minus 0.74 volt. Okay, so what will be the final answer? It will be somewhere around, it will be somewhere around 0.34 volt. It will be somewhere around 0.34 volt, because 0.74 that will become plus, so it will be 0.34 volt is not value. Cell potential is 0.34 volt plus 0.34 volt. Why? Because minus will become plus. So this one, this will be deducted from the larger value, so it will go with positive sign. So 0.34 volt cell potential we have calculated. Please remember, we are applying two equations here. One is this one. Now we are going to apply this equation now. In earlier question it was straight away we had applied the Gibbs free energy equation, but here first we have to calculate the cell potential, then we are going with the calculation for delta G naught. All of you have understood why we have applied fourth equation? Because they have given potential related to anode and cathode. Therefore, we have applied this particular equation to calculate the E naught cell. Fine. Now we have got the E naught value as 0.34 volt. We have got the E naught value as 0.34 volt. Now all of us we know whenever E naught value is positive, it should be, Gibbs free energy should be negative. Gibbs free energy should be negative. So therefore, delta G naught is equal to minus NF delta E naught. Okay, minus NF delta E naught, or you can simply mention it as E naught, because we have calculated based on these two only. So therefore, delta G naught, now important here is, what is that N value? That is important. What is that N value? So total how many electrons they are involved? For that you should go for this balanced equation. You have to go back to the balanced equation, whatever they have given. So according to that, how many electrons are involved? Here we can see that 3 2 are 6. 3 2 are 6. Here also we can see that 3 2 are 6. That means 6 electrons are involved. That's important. What is that N value are taking? That is important here. Okay. Now F value is 96,487 coulombs per mole multiplied by E naught value we have got, that is 0.34 volt. 0.34 volt. So try to write the units there only, so that finally you should have the proper units. So therefore it will be equal to minus, final answer I will write, minus 19683 joules per mole. Joules per mole. Once again, same logic. So coulomb volt, I will write it as joule, because we are talking about Gibbs free energy. Since we are dealing with the Gibbs free energy, I will using that value only. All of you have understood? Any doubts? Okay. So that's where we have the problem. So we have applied two equations, and before that we have represented the Daniell cell, galvanic cell. Fine. So this is how this type of problem has to be solved. Normally, in your case, we are not going to combine so many equations together. Individually also they can ask, but if this is the question, it can be for 4 marks, not less than that. Okay. Now we will solve another one, little bit different problem. Calculate the calculate the EMF of the cell in which following reaction takes place. In which following reaction takes place. Okay. So what is that reaction? Nickel solid plus 2Ag plus 0.0002, sorry, only 2 zeros. So 0.002 moles or molar, okay, giving rise to nickel plus 2 0.160 molar plus 2Ag where standard cell potential is 1.05 volt. Standard cell potential is 1.05 volt. Okay. Now this is the question. So they are asking to calculate the EMF of the cell. What do you mean by EMF? That is nothing but cell potential only. Okay. But where external voltage we are not gaining, it will be zero. Under that condition it will be called as EMF, electromotive force. So calculate the EMF of the cell in which following reaction takes place. So what is that reaction? That is nickel with silver ion giving rise to nickel ion and silver. Okay, this is the equation. Now they have given standard cell potential also. They have given the standard cell potential also. Now what will be the answer? Which equation we should apply among those four? Which equation we should apply? That will be the question. Right? Among those four, which equation we have to apply? We have to go with the Nernst equation, that is first one. We have to go with the first equation where E cell is equal to E cell naught minus 0.0591 divided by n log of now important one here is which is the ion which is present at the anode part. That is important. If I observe the equation, I can see that nickel is the one which is donating the electron. So therefore, it should be the anode part. So that therefore, I should mention nickel ion in the numerator. I should mention nickel ion in the numerator. So naturally, this will be the cathode ion, silver plus, but it should be twice because 2 silver ions are involved. So don't forget to mention this one. Okay? So that's what we have got the values now. What is E naught value? That is 1.05 volt. Then 0.0591. Now we have to find out what is that N value. What is the N value? Now if I see this particular equation, this particular problem, N value will be plus 2. N value will be 2 electrons because nickel from 0 it is becoming plus 2. That means there is an involvement of 2 electrons because 2 silver ion, that is plus 1, it is becoming 0. So naturally N value should be equal to 2. So log of, they have given the nickel concentration, how much it is? It is 0.16 moles. What is that silver ion concentration? It is 0.002 the whole square. Don't forget to put the whole square because there is 2 silver ion. There is the presence of 2 silver ion. Okay. So finally, after solving this, 1.0591 divided by 2, I will get 4.6021. 4.6021. We have to find out the log value. Okay, na? Next, 1.05 minus 0.14 volt, that will give the 0.91 volt. That will be your final answer. That will be your final answer. So finally it will be in terms of volt. Finally it will be in terms of volt. All of you have got the point? So that's where we have got the answer. So which equation we have used to solve this type of problem? We have used Nernst equation. So by using the Nernst equation, we have solved this particular problem. Fine? Any doubts? Okay? So anyway, I think I thought students are there. Okay, na? So that's where we have to apply a suitable equation to solve the suitable problems. So who is going to decide? That is based on the given data, based on the given information, we should decide which is that particular equation we should apply. Okay? Now we will go to the next one. Next one is related to resistance. Next one is related to resistance. Okay? Now we have an equation where resistance is proportional to L by A. Resistance is proportional to L by A. So hagadre, what is R here? R here is Raghavendra. R here is resistance. Then what is that L? L is nothing but length. What is that A? A is area, or we can tell cross-sectional area. Okay, na? So that's where we have the different terminology. R is proportional to L by A. Now same thing, I can also write it as, therefore R is equal to rho into L by A. Rho into L by A. Now what is that rho here? Rho here is nothing but resistivity. Rho here is nothing but resistivity. So resistance and resistivity, they are different terminologies. They are related to each other, but they are different terminologies. R is resistance and rho is resistivity. When it comes to resistivity, how to define? If someone asks you about the resistance, then we can tell that it is the amount of resistance or hindrance to the flow of current. That is nothing but resistance. So what about resistivity? Resistivity is nothing but a resistance of a given material when a length and cross-sectional area will be 1 or unity. What I need to tell you is, when these values will become 1, naturally rho will be equal to R. That means resistivity will be equal to resistance. So therefore, resistivity is the resistance of a 1 length meter, 1 meter length and 1 meter square cross-sectional area of substance. That is nothing but resistivity, if I want to define the resistivity. Now, when I am talking about SI units, for R, SI unit is ohm. Symbol is this ohm. Okay, for R. Naturally, therefore, for rho, that is resistivity, what will be the SI units? So to find out that one, just rearrange the equation. R into A divided by L. So that is nothing but ohm into meter square divided by meter. So meter and meter square, it will get cancelled. So therefore rho unit will be ohm meter. That will be the SI unit for the resistivity. So one mark question you can expect from this particular part. That will be the SI unit for the resistivity, ohm meter. Fine. Anyway, I will stop here. In tomorrow's class we will further continue, and from this part you can expect one mark question. From this part, that is resistance and all, you can expect one mark question. That can be related to definition or that can be related to SI unit. You can expect one mark. But from Nernst equation and Gibbs free energy and all, 2 marks question, that is problem can be asked. Fine. So anyway, I will stop here and tomorrow we will continue. Okay. So thank you.